Good afternoon, Saintsmen. We are back, semester 2. Just get a few things ready to go here. Just make sure that I'm actually going to log into my Twitch account right now. Make sure that I'm watching what's going on in case any of you guys are interested in watching the video live, have some questions for me. But really, I'm just going to jump right into the instruction for section 7.1, which is the angles of polygons. So we're going to discuss, again, we went through in the first semester, the number of sides, and then it was the type of polygon. And we had names for all these things, right? So this is just a little bit of a review, getting you guys to remember these things. So if we had the minimum number of sides we had for a polygon is 3, that of course is a triangle. And then there was a 4-sided one, which is a quadrilateral, which we're going to get into discussing in this chapter. We're going to get into the types of quadrilaterals. We're going to do some proof, because there's kind of an inadequate way to do this, right? The default quadrilateral tends to be a square, because we're going to discuss today, it's the regular polygon, but it's really maybe an insufficient way to consider the realm of quadrilaterals. I think, moreover, we're going to kind of try to default to a parallelogram, which a square, of course, is, but we'll have more on that soon enough. We have the 5-sided, which is the pentagon, of course, the 6-sided, which is the hexagon, the 7-sided, which is the heptagon, 8-sided, the octagon, and then the 9-sided, the nonagon, and 10-sided, which is the, of course, decagon. All right. So after that, mathematicians decided not really that interesting to us, right? Like we can call it an 11agon. That's a hendecagon, right? Or the 12-sided. We just called it a 12agon, even though it's a dodecagon. Not really that important, but we do need to have the vocabulary of those first 10 readily available for us. So we're going to discuss right now what the sum of the interior angles are for a polygon, for each of these polygons, and how you can find that for any polygon. Aside from, we've already done triangle, which we know. One thing is that we're going to also add to our vocabulary, again, remembering this actually occurred in the very first chapter, what a diagonal is. Remember, a diagonal is a line that's going to connect two non-adjacent vertices, okay? So here's why this is going to be important. Let's take a look. Let's take a look at a few different polygons here. I have to take off my jacket because it's going to mess up my writing here. Let's take, again, this 3-sided guy, right? The number of sides here is 3, okay? And the sum of the interior angles, as we learned, we proved it, right, was 180 degrees, because we want to go through here and be able to deductively prove what these things are. Because we're going to wind up having an explicit equation shortly, and we're going to actually do kind of a shorthand proof using angle addition on how we get this, all right? Next, we have, again, right, 4-sided, yikes, 4-sided figure, right? So the number of sides is 4. And what's the interior angle sum? Now, some students at this juncture are very excited to share with me that they know it's 360 degrees. Okay, good for you. But here's why. Here's one way for us to look at this. Let's go ahead and create a diagonal. We now have 2 triangles which have interior angle sums of 180 degrees, right? And then, what we're going to get through to create this angle right here and this angle right here is there's going to be an angle addition of these 2 angles to create this greater angle, right? That is going to be part of the polygon. So that's why we're going to be able to add in whatever these sums are, right? 3, 4, 5, and 6. And we already know the sum of 1, 3, and 5 is going to be 180. We know 2, 4, and 6 is going to be 180, right? And that the angles 3 and 4 together make up one of the angles, and 1 and 2 make up, again, one of the other angles for this quadrilateral. So here we go. Shorthand, we could put that into the form of a 2-column proof, but right now the juice really isn't worth the squeeze, right? It's one of those things, it's not really worth the work to put all that in there. But we have effectively, two triangles, and we know the interior angle sum for those guys. Put back my little diagonal here to show my two triangles. Now I can subdivide, gentlemen, every single polygon that exists, right? Next is the 5-sided figure where n is equal to 5. We know that's the pentagon, right, over here. And in the pentagon, what is our interior angle sum? Well, here we have 1, right, working from the same vertex, creating these diagonals, and we have our 3 triangles there, right? Or 3 times the 180, because we know the interior angle sum is 180, right? And we're going to share 2 angles right there, right? Sharing this guy right there, that other angle shares 2 of the angles from the separate triangles, right? Because those are adjacent to each other. So then we know that 3 times the 180 is going to be 540. So that's the interior angle sum. Now, I'm not going to even draw the 6-sided figure, right? The hexagon. We just know if n is equal to 6, it's 180 more, or we are going to do 4 times 180 more than 540, or 180 times 4, which is going to be 720 degrees. All right? So, question being, if I had n being equal to 10 for that decagon, what's going to be the interior angle sum? How do we get that? All right? And here's how we do it. Again, 180 times, let's take a look back at here. Well, it seems that when n was equal to 4, we had 2 triangles, right? Or when n was equal to 5, we had 3 triangles. And this should make sense. I'm going to explain deductively why this is the case. Because look at this, guys. If we're working from what's adjacent, right? We have those 2 other sides from the singular vertex where these are all shared. So I'm going to give this methodology. So there's there's 2 shared portions. So I'm going to have to discount those effectively in the number of sides that I'm counting. And I'm going to create 2 fewer triangles than however many sides that I have altogether. Right? Let me say that again. I'm going to create 2 fewer triangles than the number of sides I have altogether. Effectively, I'm counting triangles. I have 3 triangles here, hence 3 times 180. And a 5-sided figure. I have 4, right, triangles in that hexagon. And again, it's because I have those 2 exterior sides from that one singular vertex where I take all those triangles. So I'm going to go ahead and have my formula here explicitly. This is where we can get the sum of interior angles for any polygon. 10-sided, no problem. 10 minus 2 is 8. 8 times 180, as your calculator will tell you, is 1,440 degrees. Light work, right? So let's go ahead and do one of the examples that we'll have in the book. The sum of the measures of the interior angles of a convex regular polygon is 1,880 degrees. Classify the polygon by the number of sides. We need a little degree symbol there. So we're going to work backwards here, right? What are we solving for? Well, we're solving for n in this case, because we're going to say 180 times n minus 2, right? The number of sides, that's what n stands for. Okay? And that equals in the end 180. So this will be pretty straightforward for us, right? I'm just going to do some algebraic problem solving. Solve for n. So I'm going to divide by 180 on both sides. That's going to factor out. I'm going to have n minus 2 is equal to, oops. Guys, I'm sorry. This is equal to 1,800. My other zero didn't write. 1,800 divided by 180, okay, is 10. And of course, I'm going to add 2 to both sides. So as it turns out, n is equal to 12. That's, again, my 12agon or the dodecagon. All right. Moving on. This is going to be really similar to one of your test problems. Next portion. Hope the software will create one of these for me. Oops. Okay, so I don't want this thing to look so regular. And we're going to talk about what being regular means again. So I'm going to like kind of stretch there. Here we go. Don't worry about stuff, again, what it looks like. What is the reality here? So I have x degrees here. I have 118 degrees here. I have 111 degrees here. I have 145 degrees over here. I have at the bottom 115 degrees. And I have 124 degrees. And here, our problem asks us to solve for x. All right, well, first question we ask is, what's going to be the entire interior angle sum here, okay? So that's what we need to calculate. Well, we know the number of sides, that n is equal to 6. So what should be the total sum of all of these? Well, let's put it into our formula. 180 times, right, n minus 2, or 6 minus 2, which is 4. We already did this earlier. It's going to be 720 degrees. So we're going to go back, and we know that the sum of all of these, that x plus 118 plus 111 plus 124 plus 115 plus 145, all of that needs to be equal to 720 degrees, right? And then we just solve for x, right? You're going to add all those up, subtract them from 120, right? All these guys on this side. Those wind up being 603. Yeah, no, 613. And then you subtract from there, and we're going to get 107 for x. Okay? All right. Sorry, I was trying to do all that mental math in my head. It's been a little while, guys, with intercession and all. Let's do another one of these. 1, 2, oops. Let's try to make these as straight as I can. 2, 3, 4, 5, 6, 7. Let's label these guys A, B, C, D, E, F, and G. All right. Given that G and B are going to be congruent, E and D are going to be congruent, and then I have the following measures: 100, 160, and 140. A few questions. Is this polygon regular? Okay, and it sounds so judgmental. Are you regular? Are you irregular? But remember what that means to be regular. Regular polygons. All sides are congruent. All angles are congruent. Gentlemen, take a look. Are all my sides and angles congruent? No. So let's move on. We're going to find the measures of angles B, D, E, and G. Good news is they're all the same, right? So let's take a look. First of all, we need to think about what's the entire interior angle measure sum. So let's calculate that quickly, right? So we know our n is equal to 7. Number of sides is 7. All right? It's a heptagon. So it's 180 times 7 minus 2, which is going to give us 900. So the sum of all of these, 100 plus x plus 140 plus x plus x plus 160 plus x is equal to 900. But you guys already know there's 4 x's, there's 4 angles that are all the same, right? And then we're going to add up all those guys together. So those are going to be 100 plus 140 plus 160 is 400, right? And algebraically, we're now on the races. We're going to just solve for x, so we need to undo 400 being added, so we subtract it from both sides. So 4x is equal to 500. X, as we divide both sides by 4, is equal to 125. So that's the angle measure for each angle. The last part of this, guys, is pretty straightforward. Well, there's a formula for all this other stuff. Let's actually talk about the sum of the exterior angles. The sum for all exterior angles. For all polygons, it's the same. It's 360. This is what I mean by exterior angles. So let's say we have a pentagon. So we have a line here, line here, and here, line here, line here, right? 1, 2, 3, 4, 5. This is what I mean. Here's exterior. This guy's X. This guy is 62 degrees. This is 35 degrees. This is 69 degrees. This is 41 degrees. These are all supplementary, right? These are going to be a linear pair with the interior angle. So each interior angle has a linear pair if you were to continue the line off of it. So let's solve for X here. And this is going to be straightforward. It really doesn't matter what type of polygon it is. No matter the case, the sum of all of these together is going to be 360. So 360 is going to be equal to X plus 62 plus 35 plus 69 plus 41. And that's really straightforward, guys, right? So we're going to have 360 is equal to 207 plus X. I'm going to subtract 207 from both sides, right? And that is 53. Okay? So, gentlemen, I got a little bonus problem for you here. Thinking about what we've learned today. We're going to find the interior angle measure for a regular pentagon. I'm going to show you 2 ways to do this. And then after, we're going to find the exterior angle measure for a regular pentagon. All right, you guys ready? So think about this. We know what the sum of the interior angles is, okay? Now, if it's a regular pentagon, it means they're all the same. So I need to just divide by the number of sides, which in the case of a pentagon, we know that's going to be 5. So you could do this for every single one of these polygons, every single polygon. For a regular polygon, it's going to be 180 times, right, n minus 2 for the total number for the interior angle measure sum. But then all we have to do is divide by the number of sides, right, equally. And this is going to be your formula. So in this case, you're going to have 180 times 5 minus 2 is n is equal to 5 all over 5. Or 540 over 5, which is equal to 108. All right? Super straightforward, guys, for the regular pentagon exterior angle measure, right? Because it's all 360, every single one, pentagon, hexagon, 20agon, doesn't matter, and you divide by n. Okay? That's our little formula. So, pentagon, n equals 5. So 360 divided by 5, which is 72 degrees. Now, gentlemen, check this out. Guys, notice the relationship here? What did we already distinguish? Look, these guys were a linear pair, right? So 108 plus 72 is going to be 180. Here's the best part about this. If you wanted this answer, rather than employing this formula, couldn't you find the exterior angle, right? That singular measure and then find what's supplementary. In other words, could I just do this 72 divided by 108? Here's another way to do it. Let's do the same thing, sidebar. Interior angle of a hexagon, right? Again, 360. We're dividing by 6 in this case, which is going to be, right? 60. That's your exterior angle. So what's supplementary with that? 120 degrees, because we're going to go 180 minus 60, and that's going to give us this answer right here. So just another way to do it, another way to think about it. Good luck, gentlemen. Make sure your notes are done for the first day of class. Get a new notebook, or right now, you should be getting these notes done on a single sheet of loose leaf paper until you get that notebook, because, class starts tomorrow.